Hello everyone. In this lecture, we will discuss the applied statistics. If we recall our previous lectures, we have discussed the random variable. And random variable are of two types. One is discrete random variable, other one is the continuous random variable. And under discrete random variable, we discussed Poisson distributions, binomial distribution, hypergeometric distributions. And under continuous random variable, we have discussed your exponential distribution, uniform distribution, normal distribution. And I have told you that the normal distribution is associated with many statistical tests. Now, coming to correlate the statistics and this probability, right? These two theories, we want to correlate it. The mathematical theory of the statistics and this probability is called the sampling theory, right? So now let us know some basic facts. Then we'll go to the main topic of estimation of parameters. So let us now see what is a parameter and what is a statistics. Okay, so let us now discuss in details. As I have told you, the random variable occur frequently in many applications. Suppose a farm prepares 100 screws. Okay, coming to a random variable, 100 screws you say per hour. Now if X is getting a non-defective screw, right? This non-defective, how will get it? Under some given specification. So now this is a random variable. Now out of this 1000, suppose we want to choose a sample of size say 20, say we want to choose a sample of size 20. So we have the population here is 1000, we choose a sample of 20 here. Now one more thing I will tell here, if n is less than 30, then it is called a small sample, right? So now out of this sample size of 1000, we are choosing say 20 or any figure we choose, right? If the random sampling means if each item of the sample, random sampling means if each item has the equal chance, right? If each item has the equal chance, if each item has the equal chance in sampling, I may choose screw number 1, whatever the chances is there, screw number 20 is the same chance, screw number 1000 is also the same chance. So this is what it is called a random sampling. So now in this random sampling, you come to suppose another example. In a forest you say there are 5000 trees, that it is my capital N, is my size. So if I want to choose a sample of k is equal to 35 tree, right? 35 tree, then this 35 will be my sample here. This 35, the sample size will be my 35, right? Now this 5000 trees are associated with some random variable, say my capital X is a random variable, right? And this, as you know, the sample points of the random variable adjust the whole sample, right? Adjust the whole population, as I have told you in tossing a coin twice, right? You may get head, tail, head, or tail. So here X is equal to here 0, 1 and 2. This 0, 1 and 2 will adjust these 4 sample points here, right? So now coming to your population. As far as the population is concerned, we have here your population mean and population variance. As per your sample is concerned, we have here sample mean and sample variance. So let us now see how we'll find the mean from this population and how we'll find the mean from the given sample, right? So coming to the sample, suppose you are choosing k elements in the sample, right? So suppose x1, x2, x3, k is equal to 35, then this 35 is greater than 30 means it is a large sample here. So x is x1, x2 up to xk. If this is a unclassified or raw data, if suppose x1 occurred f1 times, x2 occurs f2 times, xk occurs fn times, then in that way we can have a frequency distribution here. Similarly, we may have a continuous frequency distribution here. We are not going to that basic statistics of all types of data, but here the my objective is to correlate the statistics and the probability. Now coming to your population, you see, out of the population, suppose out of this population I draw a random variable. This x is my random variable, x1, x2, xn, and you know the random variable are associated with a probability function known as the probability mass function, right? Now I want to find the mean. Here. So what is mean? As you know, it is summation of xi fi. It is a discrete type of distribution what we are discussing here. Similarly, it can be extended to a continuous whenever required, but here mostly as we are correlating, we will have the discrete type of this random variable here. So as you know, the summation, the sigma square, the variance is summation of xi minus mu whole square into this I have taken here pi is the probability, is my pi, right? So what this mean is called? This mean is called population mean, is not it? It is population mean. It is also called population variance. Similarly, in case of a sample, we have the mean is what? It is 1 by n summation of 1 by k here. K number of terms are, k number of items are here. So it is some I is equal to 1 to k. Now what is this mean is called? This mean is called the sample mean, right? This mean is called the sample mean. Similarly, my sample variance. So what is the formula for the sample variance? 1 by n summation of xi minus x bar whole square, right? But to be more accurate, we can replace this n by n minus 1 because I may say this x bar is very close to some xi, right? So in that case, this gap is 0 here. Xi minus x bar will be 0. So it is for a better estimate, we are taking this s square is 1 by n minus 1 summation of xi minus x bar whole square. So now we have the two things. Here is my sample mean and here is my sample variance, right? Sample variance. So I want to correlate this with population mean and population variance, right? So what we can say here is this mu and sigma, these measure here, mu and sigma, these measure associated with are the measures associated with the whole population, the entire population, and called population parameters, right? Population parameters, or we may simply call it or simply parameters. Likewise here your x bar and s square, these are called the measures associated with sample and called sample statistic or simply statistics. So my objective is to correlate these two, right? My objective is, what is my objective? Objective is to estimate statistic in terms of parameters. That means what? My x bar and s square in terms of mu and sigma square, right? So before discussing this, let me to tell you some basic terms. So as I have told, The objective is to estimate the statistic in terms of the parameter. Here one thing you note that if x bar is equal to mu, then we say x bar is an unbiased estimate of mu. If it is not equal to, then it is called a biased estimate of mu. Now coming to some basic definitions, as I have told you, the population means the whole thing. For example, the all trees in a forest, right? The sample means a part of the populations, considering 35 trees out of this, considering 50 trees out of this forest. This is called the sample. And random sampling means the process of getting the sample of desired size out of the whole population, where each member of the population has a equal chance of being included, right? Any of the item you choose, each of them is having the equal chance of being occurrence, right? Then it is called a random sampling. Now coming to the large sample, as I have told you, if the size of the sample is greater than or equal to 30, we generally call it a large sample. And what is a small sample? If the size is smaller than 30, then generally we call it the small sample. And what is sampling theory? Sampling theory, the mathematical theory of probability and statistics, and probability is known as sampling theory, right? And if we talk about a sample, right, the sample may be a raw data, may be unclassified sample. Unclassified sample means we call it a raw data, means here say x1 x2 up to some xk. Now if we just arrange according to the number of repetitions, we can have a frequency distribution here. Means the samples are arranged according to their number of times it is being repeated. It is suppose f1 times, it is suppose f2 times, if it suppose f5 times, in that way. Then coming to the continuous frequency distribution, right? Here group data means suppose some x0 to x1 it is occurred some f1 times, some x1 to x2 it is occurred some f2 times, some xn minus 1 to xn it occurred suppose fn times, right? This leads to a continuous frequency distribution, right? It leads to a continuous frequency distribution. So we are not interested here in talking about all such things, but now out of the sample, to study the behavior of the sample, we have two things. One is the measure of the central tendency, and other one is the measure of the dispersion. So measure of the central tendency means if we choose a sample of 500, means simultaneously we are not able to analyze the data as a whole. So what we want to do, we want to take the central part, right? And this mean, median and mode are the measure of the central tendency. If I correlate them, mode is equal to 3 median minus 2 mean. Similarly, for the measure of dispersion, you know your variance, you know your standard deviation, you know your range, right? But here in applied statistics, we bother about the raw data or unclassified data, right? And here we basically deal with the raw data and unclassified data. And as I have told you, here x bar is 1 by n summation of xi, and here s square is here 1 by n minus 1 summation of xi minus x bar square this is my variance, and if we find the positive square root, the standard deviation, my S is square root of 1 by n minus 1 summation of xi minus x bar square. Okay, so these are my sample mean and variance, sample mean and variance, right? So these are my sample mean and variance. Okay, so as I have told you, the major objective is to estimate the parameters. Okay, now coming to the estimation of parameters, as I have told you, what is my objective? My objective is to estimate mu and sigma square in terms of x bar and s square. Okay, our objective is to estimate the parameter in terms of the statistics. So there are two types of estimation. One is the point estimation and other one is the interval estimation. If I say suppose the IQ of a person, suppose I want to measure the IQ of a person. If I say the IQ of a student is 85, right? So we are giving a exact estimate, means point estimate. On the other hand, if we say the IQ is 85 plus and minus 5, then the IQ lies in between 85 and 95. In the second case, here the chances of accuracy is more here, right? In the second case, the chances of more accuracy here, to achieve, right? But in first case, what will happen? In first case, here my confidence is 100. In first case my 100 percentage of confidence is 100, but accuracy is little less, right? But the accuracy is little less in first case, right? Confidence is high, but accuracy, that exactly I will get 85, there is no certainty. Accuracy is little less. However, in the second case, in your interval estimate case, we have the confidence is little less, right? You say suppose 90% or 95%, or you say 99%, right? Below 90, it is not at all a confidence, right? But we may get the desired answer is quite high, but accuracy is quite high. So we prefer interval estimation over point estimation, right? Our point estimation. So point and interval estimation is better in the sense that we may get the accuracy. So coming to the definition of a point estimate, if an estimate, as I have told you, if an estimate of a parameter is given by a single number, right, is called the point estimate. And if the estimate is given in an interval, right, if we estimate the an estimate of a parameter is given an interval, and it leads to a interval estimation, right? So now for an interval estimation, we have a certain degree of confidence to get the estimation. So we will now discuss the confidence interval. Now coming to the confidence interval, if we recall the normal distribution, the probability that mu lies in a normal distribution in the interval x bar minus sigma to x bar plus sigma is 68.26%. So that means my confidence here that mu lie within this interval is 68%. Similarly, mu lies in the interval x bar minus 2 sigma x bar plus 2 sigma is here 95%, exactly 95.44%. And similarly, the probability that mu lies in the interval x bar minus 3 sigma to x bar plus 3 sigma, and it is something here 99.74%. That means I say here that that with 95% confidence we say mu lies in x minus 3 sigma x minus, it is my 99% confidence now, 99% confidence. Here it is x minus 3 sigma to x plus 3 sigma, right? In this way we can interpret this. Now this interpretation lead you to the confidence interval for the parameter under the known variance and unknown variance. So now let us see how we will find the confidence interval. Before that we also discuss some other associated terms in this context. And now coming to the z% confidence interval, or z% I can say my gamma. Z% is denoted by gamma. The interval, this x bar minus zc sigma comma x bar plus zc sigma, this zc may be replaced by simply c also, is called the interval estimate of z% confidence level, or the z% confidence interval for mu. If it satisfy probability of x bar minus mu by sigma mod less than zc, or we can say probability of x bar minus sigma less than mu and less than your x bar plus sigma is equal to z%, right? That means the interval, this interval is called the interval estimate of z% confidence level, or z% confidence interval for mu if it satisfy like this, right? Now coming to the limit of this interval, now you note that this interval is the z% confidence interval of mu. Now this lower limit and upper limit, this x bar minus zc sigma and x bar plus zc sigma, these are called the confidence limit of mu, right? And this zc, or I may call it simply c, is the confidence coefficient, or it is the critical value. If we talk about the length of the interval, then it will be upper limit minus lower limit, x bar minus zc sigma minus of x bar plus zc sigma. So this is 2 zc sigma, or we call it 2 c sigma, right? So this is the length of the confidence interval. Now for the standard level of confidence, we have to remember what is the value of c, right? For the standard level of confidence, for 90%, for 95%, for 99%, right? These are some standard confidence level, and we have to see what is the c for the corresponding this, right? What is the c for the corresponding level? So let us see now. Now at the standard level of confidence, 90 or 95 or 99, we will see what is the value of c. So in view of that, we recall here that previous normal distribution at 68.26, the interval is this. So what is the value of c here? The value of c is 1, is not it? So at 95.44%, what is the interval here? X bar minus 2 sigma, x bar plus 2 sigma, right? So this is the confidence interval. So at 99.74, it is x bar minus 3 sigma to x bar plus 3 sigma, right? So this is my confidence interval. That means for z, what is the corresponding c? As I have told you, for 68.26 it is 1. For your just a minute. So as we see, at 68%, the value of c is 1. 68% it is 1. At 99.44, the value of c is 2. At 95.44, 95.44, right? I say 95.44. The value of C will be my 2. At 99.74, the value of C is my 3. Similarly, at 50% my value is 0.674. At 90% this value is 1.645. At 95% the value is 1.960. At 99% the value is 2.576. At 99.9% the value is 3.291, right? So these are the standard value. These values are out of the normal distribution as we read it earlier. So in our context, you just remember for 90% what is the value, for 95% what is the value, for 99% these are the standard value we need to remember. For 95% the value of C is 1.960. For 90% it is 1.645. For 95% it is 1.960. For 99% the value of C is 2.576. For our purpose we need this. Now below 90%, right, it is not at all a confidence. It is not at all a confidence, right? A confidence. So we bother about this standard, and if any other thing is given, then accordingly the table will be given or the value of the C will be given itself in the question paper. Now you come to some standard estimate of mu and sigma. This estimate of mu under known variance and unknown variance you will see. So now let us discuss the confidence interval for mean mu, right? Confidence interval for mean mu when sigma square is known. So what is the working rule? At step 1, what you will do? You just select the level of confidence. Choose the level of confidence gamma, or what I call the Z%, right? Then determine your C. Means C, as I have told you, C for 90%, what is the value? For 95%, what is the value? Accordingly, this C, either it is a standard value or it is given. Then next thing is compute x bar if not given, right? Given. So this is 1 by n summation of xi. Then you apply the formula. Confidence gamma, it is x bar minus C sigma by root 10 less than mu less than x bar plus C sigma by root 10. We may write less or less than equal to. So n is my size of the sample. What is n here? Sample size. Okay, that means the value of C is known, value of x bar is known, sigma is known, this is also known. Accordingly you will find. So now if it is asked what is, suppose 95% confidence, then what is my formula here? It is confidence gamma x bar minus the value of C at 90% is 1.96 sigma by root 10, 1.96 sigma by root 10 less than mu x bar plus C sigma by C means 1.96 sigma by root 10, right? Similarly if it is 99 asked, if it is asked what is the length of the interval, it is the upper limit minus lower limit, it will be 2c sigma by root 10. So this is the idea for confidence interval for mu when this sigma square is known. Now next we will see when sigma square is not known. Now coming to one example, find a 95% confidence interval for mu and with a variance is known using a sample size of 100. So n is 100 here and mean x bar is given, right? So my gamma is my 95%. So what is the solution? Gamma is 95% means 1.960, is not it? Now your sigma is root over of this is here 3, your x bar is 5 given and here n is 100. So we directly apply the formula. Confidence gamma, it is x bar minus c sigma by root 10 less than mu less than x bar plus c sigma by root 10. So we substitute the value now. So this will be, if we calculate it, confidence of gamma, it will come around 4.412 less than equal to mu less than is equal to 5.588. We just substitute the value. The value of c we substitute, right? This is my value of c here. This is my value of c here, is not it? Value of c, value of sigma, value of n, and everything we substitute, we get this outcome. Next we will see the confidence interval for mu when sigma square is unknown. So next we want to find the confidence interval for mu when sigma square is unknown. So likewise, you choose the level of confidence gamma. From gamma you need to find the value of c. So the value of c, here you have to see the t distribution, right? So it is exactly the t distribution at 1 plus gamma by 2 with n minus 1 degrees of freedom. Means n is the number of sample size is given, it is n minus 1. We see the table here. Now what is the value of 1 plus gamma by 2? So this 1 plus gamma by 2, right? So most probably it is here 95%. If 99%, accordingly we will find. If it is 95%, here 1 plus 0.95 divided by 2 is 0.975. If it is 99%, then it will be 0.995. Okay, 995. 1 plus 0.99 by 2. So that means at this level we will see the t distribution with the level of this and the level of n minus 1. So your sigma square is not given, so you compute s square here. You know s square is without root over here 1 by n minus 1 summation of xi minus x bar square. So you compute s. Then what is the formula? Likewise the previous case, your confidence gamma is x bar minus cs by root 10 less than equal to mu less than is equal to x bar plus cs by root 10. Okay. So x bar is given. If not given, you can calculate. N is known. C you calculate out of this t distribution. S you have obtained here, and accordingly you will get the answer here, right? If x bar is not given, you can again calculate 1 by n summation of xi. If not given, okay. Accordingly you apply the. So the important thing here is to see the t distribution. I will tell you how to use the t distribution. So coming to another example, assuming normality, find a 99% confidence interval for mean mu of the following sample, right? So here sigma square unknown, right? Unknown. So for C we have to use the t distribution table, 1 plus gamma by 2 and n minus 1 degrees of freedom. We cannot use C as in the previous case, right? That 2.58 we cannot use it. We have to find it out, right? So from this given sample, what is the size of the sample? It is 1 2 3 4 5, n is here 5. So what is your x bar? X bar is 1 by 5. You add all these things, 144 plus 147, you add all these things, right? Accordingly you find here x bar will be some 144.6. then you calculate is your s square is 1 by n minus 1 summation of xi minus x bar square. So this is 1 by 4. Here 144 minus 144.6 all square. Likewise in all this case you find the scattering. If we find it out, it will be here 3.8. okay. Now you see the t distribution at 1 plus gamma by 2 with n minus 1 degrees of freedom. So this is t distribution, 1 plus gamma by 2, it is here 0.995, n is 4, and we will see the table here, and this table you will see it is 4.60. I will show you how to see this table, okay. Now you apply the formula. So confidence gamma x bar minus cs by root 10 less than mu or less than equal to mu less than x bar plus cs by root n. So if you substitute all this value, it will come around confidence gamma 140.5 less than is equal to mu less than is equal to 148.7. So this will be the desired answer. Now my job is to tell you how you will get this, how to see this table. So let us see how we can see this table. So you see here, as I have told you, t distribution at 0.995 and what is the degrees of freedom? 4. So at this level, at 0.995 level 4. So what is the value here? It is 4.60. So in this way you will see the t distribution. The t distribution table is either given to you in the exam or the value of c must be written in the question itself, right? So you should know how to see the table. We will now see the confidence interval for sigma square for variance, right? So likewise you choose the level of confidence gamma, find C1 here. C1 and C2, two things we need. In previous case we only got only one thing, C. So this for C1 you have this is chi-square table. Chi-square. So chi-square at level 1 minus gamma by 2 with n minus 1 degrees of freedom. And if you work it out, what is 1 minus gamma by 2? It is 1 minus 0.95 by 2 for 95%. It will 0.025. Similarly, it is for 99%. 1 minus gamma by 2 will be 0.005. And similarly for C2, it is chi-square at 1 plus gamma by 2 n minus 1. Like in t distribution, we got it for 95. It is 0.975. It is 0.995. Then the final formula is confidence n minus 1 s square divided by C2 less than sigma square less than n minus 1 s square by C1. You should note that always C2 is superior to C1, right? Always C2 is superior. You see the C2 level is high also, right? In view of this, so that this will be smaller than this. So this is the formula. If it is asked, what is the confidence for your confidence gamma for your sigma, then you just take the root over this is n minus 1 root over s by root over of C2, right? It is less than equal to sigma less than equal to n minus 1 root over by root over of C1 s. In that way you will find the confidence interval for sigma square as well as for sigma, right? So let us see one example. So coming to another question, you have determine a 95% confidence interval for sigma square with the following data, right? In this data you have 1 2 3 4 5 6 7 8 9 14. So here n is equal to 14 here, right? So n is equal to 14 here. So as per the formula you need all these things. So you calculate what is x bar first. X bar is equal to 1 by n 1 by 14 summation of xi. You find all such sum and finally you divide it by 14. You will find your x bar. After that you need to find what is C1? C1 is chi-square distribution at 1 minus gamma by 2 with 13 degrees of freedom. So this is equal to chi-square table at gamma is 0.025 with 13 degrees of freedom. We will see what is the value. And for C2, your chi-square distribution at 1 plus gamma by 2 with 13 degrees of freedom. This is chi-square and it is at your 1 plus gamma by 2. It will be 0.975 with here 13 degrees of freedom. And if you see it, the C2 will be around 24.74 and your C1 will be around 5.5. 0.01. Okay, then you work it out, you find it. Then what is s square? You can calculate s square, n minus 1 into s square, you just bring it. This is summation of xi minus x bar whole square. If we work it out, it will be here 326.9, sorry, it is 326.9. now you apply it in this formula. So confidence gamma, it is n minus 1 s square by c2 less than mu less than n minus 1 s square by c1. If you substitute the value here, you see the c2 is always superior to c1. c2 is always superior to c1. If you work it out, it will find confidence gamma, this value will be around 13.21, less than is equal to sigma square, and here less than is equal to here 65.25. in other way, I may write it, this confidence sigma square belongs to my 13.21 and it is my 65.25. in this way also we will able to write. So if you see this table, it will fz is here, this is fz here is 1 minus gamma by 2 and 1 plus gamma by 2. Okay, so accordingly we will see it is 0.025 with 10, it is 11, 12, 13 here. So this 13 will be here at this level. At 13 we will see that this value will be 5.01. okay, and accordingly when it is 0.975, we will see that this value will be here, it is 24.74. okay, we will see this. Accordingly we will able to see the distribution table. Let us see some more problems from the exercise. Suppose a question is find a 95% confidence interval for the percentage of cars on a certain highway have poorly adjusted brakes using a random sample of say this is my 500 is given 500, and stopped at a random sample of 500 cars stopped at a roadblock on a highway, and out of this 500 you see suppose 87 of which are poorly adjusted brakes. Okay, so total n is 500 cars, 87 of which are poorly adjusted brake. We have to find 95% confidence interval for poorly adjusted cars. Okay, so what is the probability? P is the probability of getting poorly adjusted brake. So it will be your 87 by 500. Then your Q is 1 minus P. Clear? So accordingly your Q is 1 minus P will be this much. So now here mu is equal to NP. If you solve it, N is here 500 into your P is 87 by 500. So it is equal to 87. And your sigma square is NPQ, and sigma is NPQ root over. If you simplify it, it will be your 71.862 root over. Clear? So now as it is 95%, I have told you the value of C will be 1.960 for 95%. So the value of C is 1.960. If you substitute all this thing, what is the confidence gamma? It is x bar minus C sigma by root 10 less than mu less than x bar plus C sigma by root 10. So here this mu will be for unbiased estimate for x bar. In that way you will be used here, right? So accordingly you substitute all this thing. So it will be your confidence gamma 87 minus 0.74 less than is equal to mu less than is equal to your 87 plus 0.74, right? And if you solve it, it will be confidence gamma, it will be 80 around some 86 less than is equal to mu less than is equal to some 88. Okay, because number of cars we cannot make it a fraction, so approximately we rounded it, so it is the answer. The video is getting lengthy, so we'll close it here. In the subsequent lecture we'll study the maximum likelihood estimation, what we call the MLE. So let us close here.